Alright everybody, welcome to the beginning of Chapter 10. First video that we're going to have here is going to be on Section 10.1. 10.1 is all about the idea, well, first of all, we're going to introduce some terms that are used with circles, and then we are going to talk more specifically about one of those, which is called a tangent to the circle. This is different from the tangent that you learned about in trigonometry. Same word, different use. You'll see how it plays out. You'll see some of the rules that surround it. But before we talk about a tangent line itself, we should start a little bit more at the basics. For example, what exactly is a circle? Well, you know what it is when you look at it, but mathematically speaking, a circle is the set of points equidistant. Remember that equidistant means the same distance away from a point on a plane, and we usually call this point the center. So right in the middle of the circle, we have that point that's called the center. And it's important to keep the center in mind because the center is where some of our terms are going to start from. So we need to know that this exists. One example of something like that is a radius, which is a segment with endpoints at the center and on the circle. So if one of my endpoints for a segment was the center and my other endpoint was anywhere on the circle, that right there is a radius, often abbreviated as R. A chord, which is the next word we have, is a segment again with endpoints both on the circle. So say I have a point here and I have a point here, that would be a chord. So if you ever see that word, which you will a few times within these notes, that is what a chord refers to. It's just a line that has both endpoints on the circle. A diameter is a chord that goes through the center. So it's going to have two endpoints, and it is a straight line. So what I could even do is I could take the radius that we started and then put an endpoint at the other side of it, and then connect that. This whole length then, all of this put together, would be a diameter. Which does mean that diameters are basically two radii put together, which means that the diameter is twice as long as the radius. So that is good to know. I'm going to erase a little bit of stuff on the picture just to clean it up a little bit before our next terms. So let me just clean this up. A secant is basically what would happen if you took a chord and you turned it from a segment into a line. So you have your 2 points in the circle, and basically there's your chord. The difference between a chord and a secant is that the secant will just keep going. It'll go outside of the circle. It's just a line that goes on forever. So a chord is almost like a secant segment. So a secant is a line going through the circle twice. A tangent is almost the same thing, well, at least definition-wise. It's a line that goes through the circle once. And you may be wondering how exactly that happens. Well, what that means is that, let's say we choose this point here, there's going to be a line that if we draw it just right, which I did not quite do there, let me try one more time. But there will be a line, if we draw it just right, that will sort of skim the top of the circle. And my marker here is too thick, so I can't, it's not letting me just draw it at one particular point. But the idea is that this line is only hitting the circle right at this point on the circle. So it's only hitting the circle one time. So it is a line going through the circle once. The point of tangency is where a tangent intersects a circle. Yeah, so those are most of the definitions. One more, and we're actually going to go to the pictures below for this one. Common tangents are tangent lines shared by multiple circles. So there are a few different ways that this can play out. For example, if we go across the tops of these two circles, we have one tangent line, like that. If we go down here for these ones, we've got a tangent line like that. But we also have two that you can kind of fit in between, kind of like that, and kind of like that. So we could say that this one has four common tangents. This one here, we have the one going across the top, we have the one going across the bottom, and we have this one that kind of cuts in between them. So this one has three common tangents. This one over here has two, just the one going across the top and the one going across the bottom. I didn't draw those very well, but you could end up drawing two. If we had a circle and then another circle inside of it, this would be a case where we had zero of them, because, if we make a tangent line from this circle, it's going to be cutting through the other circle completely. So that one just won't work. So that one has zero common tangents. All right, so we have these definitions, and now we're going to have a few theorems based on this idea. Then we'll see two examples that sort of use them. So, in a plane, first theorem that we have, a line is tangent to a circle if and only if the line is perpendicular to the radius with an endpoint at the point of tangency. So let's break that down. So a line is tangent to a circle if and only if the line is perpendicular to the radius. Okay, so we have radius with an endpoint at the point of tangency. So what this means then is we make our center, and let's make a radius. There it is. So for us to have a tangent line, what needs to be true is that at this point, which is the point of tangency, we have our line that we're saying is tangent. We'll know that it's a tangent line for sure if we are perpendicular to the radius that also goes through that point. Now keep in mind that what that allows us to do then is we can test out to see if something is a tangent line. One way we can do it is if we know this length here that I'm drawing in the dotted line right there. you'll notice that we formed a right triangle, and we can use things like Pythagorean theorem to help us verify whether or not we have a right triangle. So that is one of the theorems that's important for these. The other one that's going to be important here is that tangent segments from a congruent or from a common external point are congruent. So what that means is if we choose a point out here, from that point we're going to be able to create two segments that are tangent to our circle. And they're going to meet the circle at some point. If drawn correctly, which I'm doing it kind of by hand, so it may not be the most accurate, but if they were drawn accurately, these lengths here would end up being the same. And that's what that means. If you like using formulas to see things, let's call this A, this B, and this C. If AB and AC are both tangents, then AB will be congruent to AC. So if you flip to the back, we do have two examples that use this, already shown to you here. One of them is asking if AB is tangent to that symbol. There should be a circle symbol. Circle symbols are a circle with a dot in the middle, dot representing the center. So to test whether or not these are in fact tangent, or AB is tangent, all we have to do is use Pythagorean theorem. If Pythagorean theorem works, remember that means that we have a right triangle. If it doesn't, that means we don't have a right triangle, which means that AB is not tangent to C. So we're trying to see if this right here is a right angle, which means that 3 and 6 are our legs. So we're going to have 3 squared plus 6 squared, and we're going to be seeing if it equals 7 squared. 3 squared is 9, 6 squared is 36, and 7 squared is 49. 9 plus 36 is 45, which does not equal 49. So, after all this work, and you should show this work if you're asked to do this kind of problem, we can see that the answer to this question is no. Second one here, we're asked to find the length of KJ, but we know that since, one thing you do need to know is that J is an external point, and JK and JM are both tangent lines. They didn't tell you that, but it is true here. So what that means is these are the same length, which means that we can set them equal to each other. So we have x equals 12x minus 18. We could subtract 12, not x, just 12 from, yes, it would be 12x. 12x from both sides. That will give us negative 11x equals negative 18. Divide both sides by 11. And we get that x equals 18 elevenths. And that would be the length of JK. 18 elevenths would be a little bit more than 1.5. So there you have it. That is a lot of information, and basically all you need to know right now for tangent lines. You can try out the homework, some questions that are going to look a little bit like this, some questions that may challenge you a little bit on these ideas, but you're a smart group, you can figure them out. So I will see you in the next video.